How to consume a signal event in a state machine, demonstrated in Cameo Simulation Toolkit. Today we're going to look at how to consume a signal in a state machine, or more accurately put, a signal event, which represents the receipt of an asynchronous signal instance. We often speak of sending a signal to the state machine. It really means, of course, a signal event. Now, each signal event can carry specific values. We're going to look in particular here at sig with values, and it has some simple attributes here, an integer and a real. Now, you could use structured types here, but you would have to do additional unpacking of them. So we're going to keep it simple, just look at how to access these. Right, so we have a sender, has an activity that will drive the system, and a consumer. The consumer has the state machine. Now notice, before we go any further, that the sender here has a reference to the consumer we've called target, but it has here composite aggregation kind. It's important because when you run the sender, that will make sure that it creates a consumer, and the state machine for the consumer will also be started, not just the activity for the sender. Okay, so let's look at the state machine that we'll be targeting. It has a ready state, and then a transition with this signal event type here, and an effect behavior that is called effect consumer. It has state behave that has an entry with a behavior entry consumer, and exit called exit consumer. And note that it has another transition here, outgoing, and it is the outgoing transition here that will cause this to execute. Now, before we run it, I'll just alert you to the fact that the signal event that is available to the effect consumer here also, at least in Cameo Simulation Toolkit, is available to the entry. Okay, so let's have a look at these behaviors. They are trivial activities. They each take in integer and real. These match the signal attributes. That's the trick. That's the pattern that the Magic Draw and Cameo implementation uses, because apparently the UML specification does not clearly explain what you should do there. So that's a common sense pattern. Once you've got the hang of it, it's easy. So all we do is print the values that we get there with a prefix. So if you look at entry consumer and exit consumer, all they are is they have here a different prefix. They're the same. Okay, now the activity for driving this is a bit subtle. The only reason it's complicated is because I'm showing here 3 different cases. You would not normally have the same signal associated with an effect entry and exit behavior. So the only subtlety is that you read here the sender, we get the target, which is of type consumer, and we're going to send the first signal with these 2 values. We have to then wait. to have an accept event there with this accept event action with this signal type there, just so that we can see this happening before we proceed. And then we send another one. This is forked here to get the same target, but this has different values. We have here 1, 2.2, 3, 4.4. Please be mindful if you do that you use the correct literal type here. For example, if I go here, value, the way to set that is there. Get a literal integer, then edit it. It will also give you the appropriate editor. If you want a real, literal real. Don't just type something in there. Sometimes it'll work, sometimes it doesn't. So make sure you do that the safe way. Right, so we'll send that value, do a next, send another value, and then again we wait. The reason we wait is it will otherwise just finish off the sender, and it is the boss. It owns the consumer, and it will therefore inadvertently, prematurely end the state machine of the owned consumer before we can see this other stuff happening. Okay, let's give it a run. The console's down here. You can run from here by going run with context, or to show it's the same, you can also run from there. I'll do it the other way just because I want to make sure I'll try anyway to get the windows to stay the way I want. Okay, so run with context. As always, it's worth thinking about the speed. So it has created a consumer. The consumer is in the ready state. It has fetched some values, fetched the consumer, sent the signal, and in it comes to the effect. It has printed effect I equals 1, I equals 2.2, and it has gone into the entry. Entry equals I equals 1, I equals 2.2. Yes, one signal event was processed twice. All right, let's look at, let's see if I can go back here. Easy way to get there is to go to your activity here. All right, it's waiting now. Here, we want to make the exit one run. So if I go here next, it will get different values, sending them to the same target. Off goes our SIG values, and we are in the exit consumer behavior. It prints exit I equals 3, R equals 4.4. They are different values for a different signal event. The state machine is essentially done, and to be clean, we end. All right, that's it. That's all it is. There is a single slide with all the diagrams together that explains the system online with some further tips.